Hey, a very good evening to all machine learning enthusiasts. Welcome to the fourth day of amazing machine learning bootcamp on behalf of Jarvis Forum and Microsoft Learn Student Ambassador. I hope you all are pumped up and ready for another, and I can't wait to dive into the fantastic questions we have planned for you today. Before we kick things off, let me take a moment to give a big shout out to all of you amazing attendees who have joined us from different corners and are contributing to the program.
Hello. Am I audible, guys? Hello. Can anyone acknowledge me that I am audible?
Yes, Chetan, you are clearly audible.
Thank you. So, hello everyone. I'm Chaitanya and I'm back for you guys to teach you decision trees today. Thank you, Sri, for the acknowledgement. Today we are going to learn decision tree. And first of all, before learning, before moving on to the learning part, I'd like to know how many of you are new here. Is there anyone new here? Okay, I should change my question. How many of you were present in yesterday's session? Guys, I'm checking the chat box. Okay, Janvi was present, Sri was present, Prashant, Pushkar, Soham, Vaidehi, Balganesh, Sujar, Vedant, Abhishek, Aman, Vaidehi, Bontu, Abhijit. Okay, great. Thanks for the acknowledgement, guys. I hope that you enjoyed that session. So what we yesterday saw was multiple linear regression. Okay, it was a type of regression algorithm. But today we are going to see decision tree. I mean, it can be both, but today we are going to implement it in a classification way. So without further ado, let's start. So first of all, we'll look what is classification algorithm. So classification algorithm is a supervised machine learning technique that helps in predicting categorical or discrete outputs. So suppose that you have an example where you have a data set where you want to predict whether a given mail is spam or not. So how are we going to do that? So when we plot that data set on a 2D axis, we found that these are our spam mails and these are not spam mails. So what classification algorithms want to do, it wants to just classify these data points into groups, so or we can say classes, such that we can easily separate them out, and for a given input it will classify them into spam or not spam. Okay, so we can see that we give a mail as an input to our classification algorithm, and it classifies it into two spaces only, spam or not spam. So did you guys get it? What is a classification algorithm? Okay, Sri got it. Janvi also got it. Balaganesh also got it. Soham got it. Okay. Vaidehi, Sujal. Where are others? Okay. Okay, that's a great question, Janvi. So when we have a problem statement where we have output that are in a specified constrained range. So let's say that we have a problem statement that wants to predict whether the given image is a dog or a cat. So our output lies between only two values, right? We can have whether the image can contain dog or whether the image contains cat. Okay, so these are only two output. That's why it's a classification problem. So did you got it how where we apply classification algorithm? Just remember that when our output is limited to a specific range, we use classification algorithm. Okay, I hope everyone else also got it. That's a great question. Thank you, Janvi. So what is a decision tree? So do you guys know the tree model? Have you guys seen a decision, sorry, a tree structure, a technical tree structure, okay, not a natural tree structure we use in DSA, the data structures tree structure. Have you guys ever seen one? Okay, Aman has seen with Bala Ganesh. What about everyone else? You guys haven't seen, okay, Sujal hasn't seen, okay, don't worry. Yes, yes, see, it looks like a flow chart. That's a great explanation, by the way. Okay, Samir too has never seen a tree. Okay, no worries. I tell you what does a tree structure looks like. So without okay, Janvi knows about it very well. So let me dive into this topic, decision tree. So decision tree is a form of supervised learning algorithm that uses cyclic graphs to make business related decisions. So guys who haven't seen a tree, this is a form of a tree. Okay, so this right here present at the top is called as root node. Then we have okay, no issues. Payal, I've started teaching. Okay, so these are our what we call as decision node. Okay, these are called decision node, also known as parent node. And then the nodes that don't go further are called as leaf node. So those who are unaware about the tree structure, did you guys got familiar with tree? Who were they? I guess Samir and Sujal. Did you guys got familiar? Or should I explain it once again? Well, that's great. You have a data structure in your course. So that's what decision tree is. It decision tree tries to draw a certain mapping, also known as tree of our data set, and on each these node we ask some questions and split our data set. So how does we split it? Why are we splitting it? And what are the formulas behind it? We are going to look so in detail. But for now, let's see what are the uses of decision tree. So decision tree can be used for both classification and regression. Although it's a very useful algorithm, it's not prominently used in the field of data science, but it is used majorly used for just visualizing the data. So data decision tree can be used for both classification and regression. It can be used as a substitute for our previous multiple linear regression also. Then it is non-parametric. Now, what does non-parametric algorithm mean? So decision tree does not work on any assumptions. What we saw yesterday was that our linear regression was trying to learn certain parameters, right? Our weight and biases. Do you guys remember the equation of straight line we were trying to learn using linear regression? Do you guys remember it? Okay, Janvi remembers. Sri remembers. Bala Ganesh remembers. Soham also remember. Okay. Yes, that's exact the equation. Y is equals to mx plus b. Pushkar also remembers. Aditya also remembers. Great. So decision tree does not make use of these weights and biases. It doesn't learn or update any parameters. It's not parametric. It does not work on assumption, but it works on probabilities. Now you might be wondering, though, these two are the same words, right? Assumptions and parametric, sometimes used as synonym, but no, in statistics they are different. Now, what's the next best thing about decision tree is that it can handle missing data automatically. So suppose when our data set contains some of zero values or none values or null values, okay? So that becomes quite a hectic job for everyone to just see through that data set and work on it, but decision tree is a very flexible algorithm that allows us to handles missing data automatically. So let's see how to build a decision tree. Okay. So we have this data set, this customer data set here present over here, and we want to predict whether a new customer would buy a mobile or not. And how are we going to predict? We are going to predict based on these features, like what is the age group of the new customer, what is the gender of new customer, what is his or her employment status, what is the budget of the customer. And based on these features, we want to predict whether the new customer would buy a new smartphone or not. So we are expecting a binary output, right? You can see here we have only two values in this column, yes and no. So we are expecting binary output. Okay, I'll make sure that I slow down. Okay, so I'll just repeat what I said. So this is our data set. This is our data set of our uh, com- customer data. Suppose that we run a mobile store, and this is our data set we have historically present on our database, and we want to predict whether a new customer will purchase a mobile or not. So how are we going to do that? We are going to make use of these features. Okay, the age group, gender, employment, and budget. These four features we are going to make use so as to predict whether the new customer would buy a new phone or not. So this means that we expect a binary output, right? So we only have yes or no in our target variable, right? Our purchase mobile is our target variable, and we have only yes or no values. So we are going to use classification algorithm, that is our decision tree. So even though this is a small data set, we can't visually find a pattern between this data set, right? I hope you guys are present there. We'll be moving to Q&A section right now. So please guys be active and hope you have a pen and paper to remember the values you calculated. Okay. So how are we going to predict these whether a new customer will buy a mobile or not? So what we can do, we'll just start answering a few questions. Okay. So for my first question to you guys, everyone present here, my first question to you is, what is the probability of male customer purchasing a mobile? So guys, Hope you have a pen and paper to calculate these. Okay. Can I get quick responses from you? I'll wait for 2 minutes. Or if you want me to repeat the question, you can just acknowledge me. That's very fast, Janvi. Yes, it's 9 by 14. Everyone else, if you haven't calculated it, please do it. No, Cabri, it's not 6 by 8. Okay. Okay. I got it. It was my mistake, I guess. That's great. Okay, you guys are really active over there. I like, I like that. Where are others? Okay, where are others? Where is Soham? Where is Aditya? Aditya didn't send. Okay, where's Soham? Where is Aditya? You guys were active in the start, right? Well, that's a great explanation, Capway. Thank you for the explanation out there. So, time up, guys. You have taken your time. So, what what will be the probability of male customer purchasing a mobile will be total number of male customer who have purchased a mobile. So uh, we have one over here, we have second male over here, we have third male over here, three, and then there is another male, four, five, and six. So six male have purchased a mobile, and total number of male are one, two, three, four, five, six, seven, and eight. So I guess Cabway got it partially right. Okay, so it was 6 by 8 Cabway. Okay, you can see that male customer who brought mobile and total number of male customer was the formula to calculate the answer. Don't worry, we have two questions remaining. Hope you guys will be able to solve that question. So my next question is, what is the probability of a customer with medium budget purchasing a mobile? So you can make use of these two columns, budget and purchase mobile. And I'll wait for another 2 minutes for you guys to provide me the answer. That was fast, Bontu. Okay, Siri also is back in the game. Janvi is also there. Cadbury is also there. Yes, Yash is also there. Balaganesh is also there. Sujal is also there. Soham, you are back in the game, right? Okay. Who provided the exact answer? Okay. So let's move ahead. I hope everyone else also got the same answer. So what will be the probability of a customer with medium budget will be people with medium budget and who have also brought the mobile. We have those number of people are 4, and the total occurrence of medium is 6, right? We can see that how many medium people with medium budget were there. 1, 2, 3, 4, 5, 6. Okay, so 6. And people with medium who have also purchased a mobile. 1, 2, 3. And where is fourth? Okay, fourth. That's great. You guys really did it. Now for the last question. What is the probability of a customer with age group 30 to 60 purchasing a mobile? So you can make use of this age group column and this purchases mobile column. Mm, okay, Abhijit, it can never be 100. Okay, okay. Oh, you are saying probability, Abhijit. Right, right. I get it. Great, great. Okay, everyone got the right answer. Okay, it was 1. So how are we going to calculate it? So people with age group 30 to 60 who have purchased a mobile, the number of people are 4, and the total number of customers with 30 to 60 age group are 4. So we have 1 as the probability, which means that every person, every new customer who is between the range who has age between 30 to 60 will always purchase a mobile, right? So what we can see from the past few minutes is that we can split this data into subsets in order to answer our question, and the information that is derived from these splits can help us predict the outcome better, right? So we were able to predict whether a new customer will buy a smartphone if he belongs to the age certain age group, if he has certain budget, if he has a certain gender, right? So that's what decision tree tries to do. It tries to split the data set in such a way that we can ask these question and get the corresponding answers on the leaf nodes. Okay, so the nodes present at the bottom where that don't have any node below them. Those nodes are called leaf nodes. So what now we'll do, we'll try to split this data according to age group, gender, employment status, and budget. So first of all, what we'll do, we'll split this data set based on budget. So the budget attribute used to take 3 values, right? Low, medium, and high. You can see that budget used to take 3 values: high, low, medium. So we have splitted that data set based on that values. So did you guys get it how we splitted this data? Shri got it. What about everyone else? Janvi also got it. Yes, yes, yes. Okay, Bont also got it. So after splitting this data set, we see that none of these splits contain a class label that is only yes or only no. So we can see when we split on budget equals to low, the purchase mobile contains 3 yes, but at the same time it contains a single no. When we split on budget equals to medium, we have 2 yes and 2 no, and when we split on budget equals to high, we have 4 yes and 2 no's. So what this means is that just by looking at the budget value, we cannot predict if a person will buy a mobile, right? If I say that a person with low budget will has come to our shop, so will he buy a will he buy a smartphone or not? Well, the probability is between, I guess, 3 by 4, right? But we want to clearly predict, right? We want our output between 1 and 0. So this split is not useful for us. So what we'll do, we'll split on another attribute, which is gender. So first of all, we'll split based on male, and secondly, we'll split on female. Okay, based on gender equals to female. So guys, can you uh, now can you tell me whether this split will be useful for us or not? Whether this split will be useful for us or not? Okay, Sri says no. What about everyone else? Uh, no, Cabway. I hope you got the concept right. I'll just repeat the previous point. So what what okay, okay, you guys got it wrong. So I'll just repeat my point. What we want to do is split hmm, yes, Siri, yes, Siri, that's right. So when we split our data set based on budget, we see that when the customer who has budget low, when we have a budget low, the then there is a probability of 3 by 4, but we want only one probability, right? We want output to be either 0 or 1, but we are getting a probability as output. We don't want that. So this split is not useful. But when we split on budget equals to medium, we say that there are two yes and two no's, right? So it will be 2 by 4, that's 1 by 2 actually, and it's 0.5, but again we want value either 0 or 1. And same with this budget equals to high value, we have 4 yes and 2 no's. So I guess it will be 4 by 6, right? So it will be 2 by 3, 0.67. So again we are not getting a value that is fixed, it is 0 or 1. So that's why this split is not useful to us. We want a data set, a split that contains purchase mobile only, either only yes values or only no values. Okay. So now guys, can you see why this split is not useful? Yes, Bondu, that's right. That's completely right. Classification based on yes and no is required. So when we split based on gender, we see that when we split on male, we see that there are how many? 5 yes and yes, Cabway. So there are still yes and no's present in same column, right? And here it is also the same. We can see that yes and no are present in the same column. So this split is also not useful. So let's split on another attribute, which will be our age group. So age group can take three values, right? It's below 30, 30 to 60, and above 60. So let's split data set according to it. So can you guys guess, is this splitting useful or not? I guess there is also a hint present in here. No, guys, see it carefully, okay? There is also a hint present over there. Yes, the 30/60 is. So we want a split that has a subset that has only yes in its target variable column. That's what we are aiming for. So this split is actually helpful because when we split on age group, we can see that when we split on the age group value 30 to 60, the purchase mobile becomes all of the values of purchase mobile becomes yes. So we can infer one thing from this, right? That if a new customer comes, between age group 30 to 60, he will definitely buy a mobile. We can surely say that, right? So the probability of a person buying uh, of age group 30 to 60 buying a mobile phone was 1, right? You calculated it a few minutes ago. Do you guys remember? You guys got the uh, probability of 1, right? There were so many people correctly giving the answer. Okay, I hope you got it. So what this means is that this subset contains instances or these rows corresponding to only a single value, that is yes or our class label. So what does this mean? So it means that in the past, the customer of age group 30 to 60 have always purchased a mobile. So a subset that contains instances, or we can say rows, that have only one value. This subset is called as pure subset. Okay. And the rest of the subsets, the below 30 subset and the above 60 subset, were impure. So do you guys got it? What is a pure subset and what is an impure subset? So what we went through, what we just saw right now, uh, we can visualize it using a tree structure, and we are going to see it further. But first of all, we'll see that what is an impure subset. So these were the values below age group 30 and above age group 60. What we can say that these are impure subsets, right? We have yes and no in the purchase mobiles column. So we have got a first correct split, right? We have yes, Sri, that's right. The subset which has one as probability is pure subset and rest are impure. So what what will we do next? What will decision tree do next? So the next goal is to split these impure subset in such a way that we get a pure subset, right? So let me just get to the end result, but it will be quite hectic for you guys to calculate or keep on just doing the calculation. So this is our end result, and this tree structure will be it's called as decision tree. And let me just go through some points. So this diagram represent these nodes represent decision that the tree will take. I can tell all employed will buy as well. That's okay, okay, that was good one. So what we see that on each of these node, we are taking decision on how to split the data. That's what decision tree was trying to do. Hence, it is a decision tree. So first of all, on the root node, we have age group that give us the pure subset that was 30 to 60, and it was so first of all question, the decision tree is asked that whether the new customer, which age group the new customer belongs to. If he's below 30, then what is his employment status? If he's employed, then he will definitely buy a mobile, and if he's not employed, then he won't be buying a mobile. But if the person is belonging to age group 30 to 60, then it doesn't matter if he is employed or what is his gender, he or she will definitely buy a mobile. But if the person is about age 60, the decision tree will again ask a question: what is the gender of the person? If he is male, then he is going to buy the mobile, and if she's female, then she's not going to buy a mobile. So this way, decision tree helps us to ask questions and provide their corresponding answers by splitting the data. I hope you guys got it. What is a decision tree? Did everyone else got it? Yes, so leaves will always be the answer, right? Okay. So I guess now the fun part begin, guys. So we are going to dive into some mathematical formulas, and we are also going to do some of calculations. So first of all, we'll look into the steps that we need to follow to build a decision tree. So first step will be to to calculate the entropy of the target variable, which is in our case is purchase mobile. So you guys might be wondering what is entropy. So I'll show you what is entropy, but the first step is to calculate the entropy of target variable. The second step is to calculate the entropy and information gain for rest of the columns, right? So what are the rest of the columns? Age group, gender, employment status, and budget. So for each of these column, we are going to calculate entropy and information gain. So these two keywords are new to you guys. Don't worry, I'll just go through them one by one. And the step 3 is to choose the attribute with the highest information gain. So like we did right now, okay, we split the data set and we saw that we got a perfect information that when we split on age group, we have a subset that will give us a value that will give always give a single value, right? We saw that. And then what step 4 says is that we have to keep on repeating step 1, step 2, and step 3. And what step 5 says is that, well, while repeating these steps, you have to basically build the decision tree by splitting the data set. So you don't need to actually remember these steps. Now let's move what is entropy. So entropy is nothing but simply the measure of impurity within a set of data. It can also be called as measure of purity within a set of data. So when we were splitting our data set, we were trying to find a pure subset, right? The 30 to 60 age group subset was pure. So now entropy is used to determine the quality of split at each node in the decision tree. So don't worry if you don't haven't got this second line, but here is the formula, and this formula we are not going to implement today as we are going to use uh, the sklearn library for it. Now let's see how to calculate this entropy. So our first step was to calculate the entropy of target variable. So let's say that we have this purchase mobile column over here. So guys, can you tell me what are the number of yes and no in this data set? I'll repeat the question. Can everyone tell me what is the number of yes and what is the number of no in this data set? 9 yes. Okay, that's great. You guys are really fast at we at seeing the data set. That's great skill to have. So yes, we have uh for 9 yes and 5 no's. So now I'll ask another two question. What is the probability of yes and what is the probability of no? Or what we can say is that what is the so I'll just tell the formula for it. It is okay. I don't need to say about it. You guys are already aware of it. Great. Yes, so it's 9 by 14 and 5 by 15. So what is the entropy of this target variable? So it will be 9 by 14. So it's the what this formula reads is probability of yes into log 2 into probability of yes plus probability of no log 2 probability of no. So you can see that probability of yes was 9 by 14 into log of probability of yes plus probability of no into log of probability of no. And when we calculate this, we get this value 0.94027. So guys, did you got it? How we got this entropy? How we got this entropy? Did you got it? Great. Now, what was our second step? It was to calculate the information gain and entropy. So we'll first look into what is the information. So firstly, we what information for calculating information gain, what we'll do, we'll split the data set on the age group, and based on the that split, we are going to calculate entropy of each subset. Yes, Sri, you just need to remember. So these are the values calculated. I've already done that so that you guys don't have to go through those hectic calculation over there. So it was 3 by 5. So probability of yes into probability of yes plus probability of no into probability of no. But on the split 30 to 60, we only had probability of yes into probability of yes. As you can see that there is no in this data set in this split. So the we I haven't wrote that term. So did you guys got it? How we calculated this entropy of these three subset? Okay, Cadway got it. What about the others? Janvi also got it. Soham also got it. Great. Okay. I'll repeat it, Siri. So what for calculating the information gain, we want what we'll do, we will split on attribute, age group attribute. So we have values, what the age group had values were below 30, 30 to 60 and above 60. So after splitting these the age group into three three subset, we are going to calculate the entropy for each subset. So do you remember the uh, entropy formula, how we calculated the entropy just right now? So it was like there are three no's here, so three, and total number of data points are five. So 3 by 5, so it becomes probability of no into log of probability of no plus there are two yes. You can see here there are two yes and total number of rows here are 5. So probability of yes into log of probability of yes. And similarly, we see that the calculation of 30 to 60 and above 60. I hope you got it. So what I'll do, I'll just drag these values over here. Now we want to see that proportion of below 30 instances. So there is, I guess there is no picture present over here. So what I'll just show the answer. So it was like, what is the probability of a person who is below 30, and what is the probability of a person below 30 buying a smartphone? It was 5 by 14. Yes, you can ask. And the proportion of 30 to 60, also what was the proportion of people who were belonging to 30 to 60 in the whole data set? It was 4 by 14, right? So I think I'll just show you guys how we calculated this proportion. So how we calculated this below 30 proportion. So I'll just move back to our main data set. Yes, you are going to see why we need probability of that also. So we can see that there are one, two, uh, three, four, and five. So we can see there are five instances of below 30 customers in the age group dataset, in the age group column, and the total number of rows here are 14. That's why the proportion of, or the probability of, below 30 people buying a smartphone was 5 by 14. So I'll just go back over there and present it again. So that's how we got these values: 5 by 14, 4 by 14, and 5 by 14. Now we are going to calculate the weighted average entropy, and it's quite simple to answer, but here is the what what I just said, weighted average entropy. There is no correct formula for it, so I've just wrote the answer. So it is proportion of below 30 instance into its entropy plus proportion of 30 to 60 instance, which is 4 by 14, into its entropy plus 5 by 14 multiplied by its entropy, and summation of all these multiplication, we get this weighted average entropy. Did you guys get it? How we got the weighted average entropy? Okay, Sri got it. What about everyone else? Capsu also got it. Great. Where is everyone else? Janvi got it. Soham, Sujal. Okay, nice. Bala Ganesh also got it. So we have calculated our weighted average entropy. Now I'm going to show you the formula for information gain. The information gain formula is starting entropy. So the entropy that we found for our target variable, right? So the entropy that we calculated in first step minus the weighted average entropy that we calculated right now. So starting entropy was 0.94027 minus 1.02017. You guys might not remember, or some of you guys might remember these values, and the information that we gain after splitting on the age group attribute is this. So what a decision tree will do, it will keep on calculating this information gain on all the four attributes: our age group, our gender, our employment status, and the budget of the customer. It will keep on calculating entropy and information gain of these attributes, and keep on selecting the attribute that gives the maximum information about itself. So what it's basically trying to do, it's trying to give us the pure subset. This I hope you got it. What or you remember the what is a pure subset, right? So that's what decision trying to do, recursively repeat these calculations for each column. That's how we got that end result over there. We right, you can see, yes, here it is. So that's how decision tree will get to this tree. That's how it will build this tree. Okay, everyone else got it? If you have any question, uh, just ask it now, cause we will be moving to the most fun part that you guys always wait for, the coding part. Great, Janvi is excited for the coding part. That's great. So let's code. So guys, open up your collab. No, firstly go to your GitHub. Go to your GitHub and open your repository of ML Bootcamp, and just go to SyncFork and update your branch. Let me just see that whether the changes I did are present on here. Okay, present. So just go to your forked repository and click on SyncFork and update the branch. Okay, update the branch. And guys, please acknowledge me, those who are done. Great, Bonto did it. Nice. Sri Soham also did it. Great, great, great. Now, guys, those who remember the how to open the collab, just uh, do so. Sorry for the issue. So it was just go to your collab. Yes, we can. You can just sync the fork. So I'll be providing the code for today in the chat box also, cause we do not have the pre already codes present today. We are going to do live coding. So on the collab, open the week 2, day 2 code.ipynb. I hope it's visible. Open this file, guys. Okay. After opening, can everyone just acknowledge me that you guys have opened this code file? Okay, Sri has opened it, Soham did it. Where is everyone else? Where is Cabway? Where is Sujar? Bonto also did it. Bala Ganesh also did it. I was just going to say your name, guys. Collab file, and I guess it's taking its time. Why is it not closer? So connect your runtime, guys, because we are going to. It was 2003. Okay. So Cabway, just go to your file, open notebook, and in the GitHub section, you can use open ML Bootcamp. This, okay. Can you see it on the screen? Week 2, day 2, code.ipynb. Can can you see the screen, Cabway? You have to open this file. Week 2, day 2, code. Yes, it's from GitHub. Okay, Samir did it. So just open that file. I'm already present, so that's why it's that much quick. So in first cell, we are importing these libraries, and these will help us in further calculations. To run the first cell, I'll just zoom in to what I'm typing so you guys can see clearly. And then we have run the first three cells, and you can add cells below these three cells by clicking on this code button available over here. So when you click it, there you go. There is a code cell available. So after this, what we'll do again. So now I'm going to I'll just explain what were these first three cells doing. So the first cell was importing these libraries. Second cell was cloning the repository into the collab environment, and uh, on on our GitHub repository we have added a data set for you guys. So we it was a zip file, so we used unzip to unzip that file, and we got a mushroom.csv file. So we just read it using the pandas library using this line. So I'll just post this code into the chat box. You guys can copy and run that cell. Okay, just keep running, and then you can see this data set. Oh, I forgot to mention what today we are building. Okay, so today we are building a mushroom classification using decision tree that will help us classify whether a given mushroom is poisonous or edible. So this is our data set. Our data set, the first column of our data set is our class, basically our target variable. That, and within this target variable, you can see that it takes value p, gives value p and e. So p stands for poisonous, e stands for edible, and these are the features of the mushroom. Now you guys might be wondering how many features does this dataset have. So this dataset has 23 features, and the total number of examples that it has is 8,124. That's a quite big amount of data, right? We can't infer anything from this dataset, but decision tree is here to help us. So did you guys got it? Can you guys see the data set on your screen? Okay, not on the presentation screen, on your screen where you are coding. If you are unable to see, just acknowledge me. I'll post the code again in the chat box. Okay, so you guys got it. Now, the main thing that every data scientist wants to do first is to find whether our data set contains null values. So, how are we going to find it? So, there is a built-in function in Python that is null. What this function will tell is that whether a null value is present in the data set in these columns. So we can see that there is no null value present in the data set. I'll just copy this code and paste in the chat box. Right. And just for the sake of clarification, we are also going to see what is the total number of null values. So is null dot sum. So when you run this cell, we can see that these are our columns, and there is literally no null value present in our data set. Well, that's great. This means that our data set is already clean. So did you guys got this? Okay, so I haven't posted this code. As soon as you guys get this output, please acknowledge. Great, great, great. So now, as we did yesterday, we are going to get insight about this data set. So we now know that it doesn't contain any null values, but getting familiar with it is very helpful. So what we'll use the describe function that is present in Python already. And so what we can see that number of unique values in each column, and what is the most prominent value in each column, and what are the total number of values in each column. Okay, that's what this describe function helps to see. Okay, now next what we want to do is we want to see how many poisonous and how many edible examples we have. So what we'll do, we'll just go to data set and class. Yes, sure. Just wait a second. value counts. So what this line will do, it will help us to see how many examples are there with the class poisonous and edible. So when you run this cell, you will get this output that the example number of example for edible mushroom is 4208 and the number of example for poisonous is 3916. So I'll just copy and paste this in the chat box and the next code also. Guys, acknowledge me that you got it till here. Great, great, great. So, so now what we want to see is that whether our data set is categorical, right? So we want to see that uh, our data set contains categorical value, like we saw in the example we took in the theory session that the attribute such as age group contained only three categories, right? Below below 30, 30 to 60, and above 60. So that's what we want to check that whether each of our column is categorical. So what we are going to do? Data set as type, type category, and your dot data types. So what these two line of code will help us uh, evaluate is that our data set would contains categorical columns or not. So we can see that each and every column, each and every feature is categorical in our data set, right? So now, as we already know that we cannot perform any uh, mathematical formulas or calculation on string values, right? You can see that this data set contains string values e, x, y, n, f, n. So we cannot apply any mathematics on these values. So what we want to do is we want to convert it into certain numbers, right? So what we'll simply do, we'll use encoding. So what encoding will do, so suppose that this class function contains two unique values. So the two unique values are p and d, poisonous and edible. So what the label encoder will do, it will assign 0 to e and 1 to p. Similarly with cat shape, there are six unique values in it. So what will do, it will replace x with zero, other alphabet that are like WBC with 1 2 3 numbers. I'll just show you guys how to do that. So for doing that, we are going to use sklearn library from sklearn dot processing. Okay. import label encoder, and we are firstly we will import the label encoder from the sklearn library. Then we'll initialize it, and then we are going to apply it in every column. So for every column in our data set dot columns, what we want to do is we want to apply we want to do is we want to apply the label encoder and transform the data set into numerical value. So data set column. And I'll just paste this code. I'll just paste this code in the chat box so you guys can see it. So run this code and again visualize the data set. You will see that tada, our string values are converted into numeric values, right? You can see it. So those who have reached till here, just acknowledge, and those who haven't, please post your screenshot of your error in the. Okay. Sure, yes. So what the problem was that in when you saw your our data set, we saw that our data set contains the string values, okay? But we cannot perform any mathematical calculation on these string values, right? We need numerical values to perform calculations on. So that's why we are using encoding techniques so that we can represent these string values into numerical values. So how are we going to do that is, so I'll just get an example. So this class column has two unique values. So it has two unique values, P and E. So what the encoding will do, it will convert the P value into 0 and E value into 1. Now same with the cap shape, it contains six values. So what it will do, it will replace X with 0 and the other values with 1, 2, 3, 4, 5. Now did you got it, Yash? Okay, Bontu, you got that error. So what you can do, Bontu, is you can drop a screenshot of the error along with the code on the group, and the team will try to get it solved. Okay, because I cannot just guess what is the error you are facing. So everyone else, did you reach till here? Did your data set values got converted into? Okay, Siri. Okay, so got it. Siri is trying to help on to. That's great. Capway also got it. Great. So today no one is left behind, I guess. So now when we use our describe function on this data set, it will provide us more information now. Oh, shit. I forgot So, so now you can see that it has performed certain mathematical functions on mathematical calculation on the data set as its numerical, and we can see that it has calculated mean, standard deviation, minimum value, and the maximum value also. So just remember that after that we always need to convert the string values into numeric values, sometimes into vectors to speed up our calculation, or just simply apply mathematical functions on the data set. Now, guys, I'll show you how to drop date column from our data set. So you can, as we saw that there are 23 columns over here. Now we are not going to use all of these columns, right? We don't want to ask the customer 23 questions that describe yourself. How are you going to, what is the color of the mushroom? What is front color? What is cap surface? How its cap color is, right? We don't want to do that. So we definitely want to drop some useless columns, right? So I'll just show you how to drop a column. of Data set dot drop. We'll type, and the axis should be 1. What axis 1 is trying to say is that we want to drop the column. Okay, defaultly it is set to 0. That's why I've specially told it that no, I want to drop the column. And then when we again see our data set, we can see that we have dropped one column, and the number of is reduced from 23 to 22. I'll provide this code in the chat box. So guys, did you got it? How to the drop columns from a data set? Everyone, where is everyone? Hello. Yes, Bala Ganesh is here. Soham is also here. Where are the other guys? Are you guys coding along with me? Yes, it's a hassle. Yes. So what we are going to do, we will be using a very useful function provided to us by sklearn. I just wanted to show you how to drop only a single column from the data set. Now what we'll do, we will split our data set into two parts. So one part will be our x values, which will be, sorry, first we'll initialize the y value, which will be the set. So what in these two line of code, what we are trying to do is we are trying to separate our target variable and our features. Okay. So after running this cell, what you can see that Y contains our class, right? This is our class, and X contains our features. Yeah, so I'll just provide this code in the cat box also. Guys, just acknowledge me that should I move further or should I wait for you guys? Yeah. How many of you are done till here? How many of you have done till here? Bala Ganesh is done till here, has done till here. Vaidehi, Soham, Abhijit, great. Pushpa is also here. Please go back a bit. So Kabe, your X is showing 22 columns or 21 columns? Samir is also done. So now, okay, so I guess you haven't wrote this formula correctly. Okay, okay, Payal, I'll just wait. Now, so Cabway, what you haven't wrote is this cell. So I've just highlighted the cell you haven't wrote, and I'll also paste the code over here in the chat box. So write this code first and then this code. Okay, you can see that this code, just write this code and then run that cell, then run this code again, and you'll see 21 columns. So did you got it, Cabway? And everyone else, did you got it till here? Till we have done the splitting X and Y? Great. That's a quick reply, Yash. So now what we'll do, the next, so in machine learning, what we want to do is we want to split the data set into three sections. One is our training, second is our testing, and third is our validation. So training set is for training our machine learning model. Testing is for, as the name suggests, it is basically testing our model, how much correctly it guesses on the same data. And validation set is the set unknown to the model, and we want to check how well the model performs on unknown data. So we'll implement it right now. So for that also we are going to use the sklearn library, and we are to use and import the okay. Now is it visible? Then just split. So we first we import it, and then so what so in this first line what we are what we are doing is we are importing the trend test split available in the sklearn library, and in the next line we are splitting the dataset into training and testing, but we haven't split the dataset into validation set, right? So I'll just first run this cell, and I'll also copy this code into the chat box. And now we are going to split the dataset into validation also. So xtrain xval and y train y validation is equals to, and yes, I know. Random state equals to, it was it 42. So don't worry if you don't know what I am trying to code. So in this line, okay, so Yash, what is this? What is the use of this test size? The test size will make. Okay. Uh, Let me just frame the statement right. So we want to split our data set into training and validation first, right? But what is the proportion of test set we require and what is the proportion of training set we require, right? So it is basically the test size. So 20% of our data will be used for testing, and the remaining 80% of the data will be used for training. And the random state here signifies that after how many rows we will be picking a random column and set. I have gotten an error as wild type not found in the access in the last second cell. So Sujal, that means that you have already ran that cell and your dataset doesn't contain that well type cell, well type column. So you just need to run the codes afterwards. The codes are sent afterwards. So uh, what this line of code is trying to do, it is trying to split the dataset into training and testing. And what this line of code trying to do, it is trying to split the dataset, split the training dataset into training dataset and validation dataset. So I've provided the code that I just wrote. So guys, kindly acknowledge me that you are done till here, till the splitting part. Okay, Vaidehi has done it. Bala Ganesh has done it. Soham has also done it. Bontu has also done it. Great. And what about you, Sujal? Did you rate? Yes, yes, Cadway, just run the code. Okay, done. So now what we'll do, we'll import the decision tree classifier from sklearn. Decision tree classifier, and also another helping function that I'm going to tell what it is going to do. Sklearn dot selection. to- So uh, for in the first line of code, we imported the decision tree classifier, and in the second line of code, we imported the RFE feature selection method provided to us by the sklearn library. So now you guys might be wondering what is feature selection. So as the name suggests, feature selection is what trying to do. It will drop some of the unnecessary columns from our data set and make the model training easy for us. So we won't be having any useless columns in our data set. So I'll just drop this code in the chat box. And now since we have imported it, firstly, what we'll do, we'll just initialize the model. So model is equals to decision tree classifier, right? And then uh, equals to and we also need to provide this code, right? So now we have initialized our decision tree classifier and we want to select the best features that will help us make our training quite a bit easy for us and the reducing the size of the data set. So we are going to use the RFE feature selection method available in sklearn, and we are going to apply it on our model. So we initialized our model on the decision tree classifier, and then our RFP dot fit on X train on Y train. So we initialized our RFE in this line of code, and now we are going to fit it on the training dataset so that it can find the best features to fit our data, our decision tree classifier on. So I'll also provide this code. So guys, kindly acknowledge me that you got it till here. Did you guys got it till here? Just acknowledge. And if you have any error or any doubt, you can ask. Okay, Bala Ganesh is very fast. Okay, Cabway got an error. So Cabway, on which code did you got error? Can you just paste the code and the error also in the chat box? Till then, what we want to do is we want to find which of the which features did the algorithm select. So what we'll do, we'll just extract those features. Okay, so you Gabby, did you ran this cell, this sklearn this cell, the import cell? Okay, Gabby did it. Okay, great, sorted. Okay, great. Support. Okay, so the code after that is this. This is the code after that. I can't see my screen. So guys, can kindly acknowledge that are you able to see my screen? Okay, okay. So what these three lines of code is trying to do, first of all, it is trying to extract the indices from the RFE that just found the best fit columns for our for our model. Then we want to get the name of those columns, right? So uh, from 21 columns, we can see that uh, the most related columns are gill size, gill color, stock root, stock spore print color, and population. Cabway, I just did it, so it was after this one. Mm. Then this. So everyone else just acknowledge me that did you guys reach it till here? Did you guys can you guys see how what are the most beneficial columns in our data set? Bala Ganesh, only Bala Ganesh got it. What about my series or has also got it? What about the others? There was Soham, Sujal, Abhijit. Where are you guys? Janvi also got it. Okay, Yash also got it. Where are the others? Guys, are you getting any error? Okay, Sujal is back. Okay, great. Now I'm error for this one. Selected feature indices. Okay, so Capway, there is uh, on the so you have to write the selected feature names on the next line. Okay, that's so yes. Actually, I have already built this classifier quite a many times, and that's how I got the to know that when I keep the selected columns to 5, then the model gives the best output. That's why I set it default to 5. You can play around the with this value, the number of features value. You can set it lower than that, like 4 or even 3 or even 2 or 1. But as I know that only 5 columns are required for the model to perform well. That's why I wrote it. So that way, did your error got solved? I'll just post this column once again so that So now what we'll do, we have found the best fit columns that provide us the uh, optimal machine learning model. Now what we want to do is we want to drop other columns, right? We don't want to use the other columns since we know what will be the most useful column. We are going to drop those columns and using these lines of code and run that cell. So, Cabsway, did you got it till here? And everyone else just acknowledge me because we are just one line away from training our model. Just a single line of code is read next. Okay, Bontu has did it. What about other? Bala Ganesh has also got it. Great, great. Yash and Pushkar also got it. Great. So I guess I'll move forward and what's the next thing to do is model dot fit on the x underscore frame selected and also on the y frame. So using just this line of code our uh, so that's it. We have trained our decision tree classifier model on mushroom classification dataset. Now we also want to visualize these data set, these decision tree, right? So I'm going to write quite a few big lines now. Don't worry if you don't got it. So I just don't forget about it. What I'll just do is just open the folder and it was becoming too hectic for me to write the code for it. Okay. So I'm going to provide the code in the chat box. Now you guys might be wondering how I wrote this code. So this code is actually available on this GraphViz library documentation. It is provided there only. The team has given a quite a long definition of what is each and every line trying to do in this in this line of code. So make sure guys you go and check it out and run that cell. You are going to see a magic. And those who saw that magic, kindly acknowledge. Okay, Bala Ganesh saw the magic. Great. What about everyone else? Okay, Sri, I'll wait. Okay, you can't paste the code, so okay. What I'll do, I'll just provide the code line by line. Okay. So this was the first line. This was the second line. This was the third line. Yes, yes, capture. Uh, so what we have to do is what you guys have to do is capture that the lines of code that I just provided right now. You have to write those lines in a single cell and run that cell. I haven't run that cell, so as you guys can see the magic yourself. Uh, no Cadbury, it's the same. It's the same. Now, not only that part, but also the line of code that I provided after that. You can see that dot data and then graph and graph views. I don't want to reveal the magic to you until you do it. So, guys, everyone else, kindly acknowledge me that have you seen the magic happen? Okay, okay. I'll wait, Sri. I'll wait. Okay, Siri got it. So, Capway, did you got it? Okay, I was writing something in the chat. Okay, Janvi also got it. Yes, it surely is. Pushkar got it. Great. Now I'll show. Okay, I guess it's good. So here is a decision tree that we just learned right now. So that's it, guys. Congratulations, you have successfully built a mushroom classification model that will predict, or we can say that it will classify the user sample into edible and poisonous mushrooms. So that's it for today's session. Thank you guys for being a patient listener and hope you guys enjoyed the session. You may leave now. Thank you. Yes, Cabway, do you remember the steps to submit this assignment? There is, okay, so just do it. You have to go to week 2, day 2, and in the submission folder, you can upload those files. And what my team will do, it will just write submission.md file in the open so that you can get quite a hint about it, how to do the submission. Actually, we are running late. That's why I had to close the meeting early. So thank you guys for being a active participant.